Section 4A of National Geographic Magazine, Volume 1, Number 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Kelly Dolan. The Rivers and Valleys of Pennsylvania, Part 4A, by William Morris Davis. Part 4th. The Development of the Rivers of Pennsylvania. 23. Means of distinguishing between antecedent and adjusted consequent rivers. The outline of the geological history of Pennsylvania, given above, affords means of dividing the long process of the development of our rivers into the several cycles which make up their complete life. We must go far back into the past and imagine ancient streams flowing down from the Archean land toward the Paleozoic Sea, gaining length by addition to their lower portions as the land grew with the building on of successive mountain ranges. For example, if there was a Cambro-Silurian deformation, a continuation of the Green Mountains into Pennsylvania, we suppose that the pre-existent streams must in some manner have found their way westward to the new coastline. And from the date of this mountain growth, it is apparent that any streams then born must have advanced far into their history before the great Appalachian disturbance began. At the beginning of the latter, as of the former, there must have been streams running from the land into the sea, and at times of temporary elevation of the broad sand flats of the coal measures. Such streams must have had considerable additions to their lower length, rising in long-growing Archean highlands or mountains, snow-capped and drained by glaciers for all we can say to the contrary, descending across the Green Mountain belt, by that time worn to moderate relief in the advanced stage of its topographic development, and finally flowing across the coal measure lowlands of recent appearance. It was across the lower courses of such rivers that the Appalachian folds were formed, and the first step in our problem consists in deciding, if possible, whether the streams held their courses after the antecedent fashion, or whether they were thrown into new courses by the growing folds so that a new drainage system would be formed. Possibly, both conditions prevailed, the larger streams holding their courses little disturbed, and the smaller ones disappearing, to be replaced by others, as the slopes of the growing surface should demand. It is not easy to make choice in this matter. To decide that the larger streams persisted and are still to be seen in the greater rivers of today, only reversed in direction of flow, is certainly a simple method of treating the problem. But unless some independent reasons are found for this choice, it savors of assumption. Moreover, it is difficult to believe that any streams, even if antecedent and more or less persistent for a time during the mountain growth, could preserve till now their pre-Appalachian courses through all the varying conditions presented by the alternations of hard and soft rocks through which they have had to cut, and at all the different altitudes above base level in which they have stood. A better means of deciding the question will be to admit provisionally the occurrence of a completely original system of consequent drainage, located in perfect accord with the slopes of the growing mountains. To study out the changes of stream courses that would result from later disturbance and from the mutual adjustments of the several members of such a system in the different cycles of its history. And finally, to compare the courses thus deduced with those now seen. If there be no accord, either the method is wrong, or the streams are not consequent, but of some other origin, such as antecedent. If the accord between deduction and fact be well marked, varying only where no definite location can be given to the deduced streams, but agreeing where they can be located more precisely, then it seems to me that the best conclusion is distinctly in favor of the correctness of the deductions. For it is not likely, even if it be possible, that antecedent streams should have accidentally taken, before the mountains were formed, just such locations as would have resulted from the subsequent growth of the mountains and the complex changes in the initial river courses due to later adjustments. I shall therefore follow the deductive method thus indicated and attempt to trace out the history of a completely original, consequent system of drainage, accordant with the growth of the central mountain district. In doing this, it is first necessary to restore the constructional topography of the region, that is, the form that the surface would have had if no erosion had accompanied its deformation. This involves certain postulates which must be clearly conceived if any measure of confidence is to be gained in the results based upon them. 24. Postulates of the argument. In the first place, I assume an essential constancy in the thickness of the Paleozoic sediments over the entire area in question. This is warranted here because the known variations of thickness are relatively of a second order, and will not affect the distribution of high and low ground as produced by the intense Permian folding. The reasons for maintaining that the whole series had a considerable extension southeast of the present margin of the Medina sandstone have already been presented. In the second place, I shall assume that the dips and folds of the beds now exposed at the surface of the ground may be projected upwards into the air in order to restore the form of the eroded beds. This is certainly inadmissible in detail, for it cannot be assumed that the folded slates and limestones of the Nittany Valley, for instance, give any close indication of the form that the coal measures would have taken had they extended over this district, unworn. But in a general way, the Nittany Massif was a complex arch in the coal measures as well as in the Cambrian beds. For our purpose, and in view of the moderate relief of the existing topography, it suffices to say that whenever the lower rocks are now revealed in anticlinal structure, there was a great upfolding and elevation of the original surface, and wherever the higher rocks are still preserved, there was a relatively small elevation. In the third place, I assume that by reconstructing from the completed folds the form which the country would have had if unworn, we gain a sufficiently definite picture of the form through which it actually passed at the time of initial and progressive folding. The difference between the forms of the folds completely restored and the form that the surface actually reached is rather one of degree than of kind. The two must correspond in general distribution of height and low ground, and this is the chief consideration in our problem. When we remember how accurately water finds its level, it will be clear that what is needed in the discussion is the location of the regions that were relatively raised and lowered, as we shall then have marked out the general course of the consequent waterways and the trend of the intervening constructional ridges. Accepting these postulates, it may be said in brief that the outlines of the formations, as at present exposed, are in effect so many contour lines of the old constructional surface, on which the Permian rivers took their consequent courses. When the Trenton limestone is now seen, the great amounts of overlying strata must have been removed. Hence the outline of the Trenton Formation is our highest contour line. Where the Helderberg limestone appears, there has been a less amount of material removed. Hence the Helderberg outcrop is a contour of less elevation. Where the coal beds still are preserved, there has been less wasting, and these beds therefore mark the lowest contour of the early surface. It is manifest that this method assumes that the present outcrops are on a level surface. This is not true, for the ridges through the state rise 1,000 feet more or less above the intervening valley lowlands, and yet the existing relief does not count for much in discussing the enormous relief of the Permian surface that must have been measured in tens of thousands of feet at the time of its greatest strength. 25. Constructional Permian topography and consequent drainage. A rough restoration of the early constructional topography is given in Figure 21 for the central part of the state, the closest shading being the area of the Trenton limestone, indicating the highest ground, or better, the places of greatest elevation, while the Carboniferous area is unshaded, the early lowlands. The prevalence of northeast and southwest trends was then even more pronounced than now. Several of the stronger elements of form deserve names for convenient reference. Thus we have the great Kittatinny, or Cumberland Highland, on the southeast, backed by the older mountains of Cambrian and Archean rocks, falling by Kittatinny slope to the synclinal lowland troughs of the central district. In this lower ground lay the synclinal troughs of the eastern coal regions, and the more local Broad-Top Basin on the southwest, then better than now deserving the name of basins. Beyond the corrugated area that connected the coal basins rose the great Nittany Highland and its southwest extension in the Bedford Range, with the less conspicuous Kishicoquillas Highland in the foreground. Beyond all stretched the great Allegheny lowland plains. The names thus suggested are compounded of the local names of today and the morphological names of Permian time. What would be the drainage of such a country? Deductively, we are led to believe that it consisted of numerous streams, as marked in full lines on the figure, following synclinal axes until some master streams led them across the intervening anticlinal ridges at the lowest points of their crests, and away into the open country to the northwest. All the enclosed basins would hold lakes overflowing at the lowest part of the rim. The general discharge of the whole system would be to the northwest. Here again we must resort to special names for the easy indication of these well-marked features of the ancient and now apparently lost drainage system. The master stream of the region is the great Anthracite River, carrying the overflow of the Anthracite lakes off to the northwest, and there perhaps turning along one of the faintly marked synclines of the plateau and joining the original Ohio, which was thus confirmed in its previous location across the Carboniferous marshes. The synclinal streams that entered the Anthracite lakes from the southwest may be named, beginning on the south, the Swatara, the Wiconisco, the Tuscarora Mahonoi, the Juniata Catawissa, and the Wyoming. One of these, probably the fourth, led the overflow from the Broad Top Lake into the Catawissa Lake on the middle Anthracite River. The Nittany Highland formed a strong divide between the central and northwestern rivers, and on its outer slope there must have been streams descending to the Allegheny lowlands, and some of these may be regarded as the lower courses of Carboniferous rivers that once rose in the Archean mountains, now beheaded by the growth of mountain ranges across their middle. 26. The Jura Mountains, homologous with the Permian Alleghenies. However willing one may be to grant the former existence of such a drainage system as the above, an example of a similar one still in existence would be acceptable as a witness to the possibilities of the past. Therefore, we turn for a moment to the Jura Mountains, always compared to the Appalachians on account of the regular series of folds by which the two are characterized. But while the initial topography is long lost in our old mountains, it is still clearly perceptible in the young Jura, where the anticlines are still ridges, and the longitudinal streams still follow the synclinal troughs. While the transverse streams cross from one synclinal valley to another at points where the intervening anticlinal arches are lowest. We could hardly ask for better illustration of the deductive drainage system of our early Appalachians than is here presented. 27. Development and adjustment of the Permian drainage. The problem is now before us. Can the normal sequence of changes in the regular course of river development, aided by the post-Permian deformations and elevations, evolve the existing rivers out of the ancient ones? In order to note the degree of comparison that exists between the two, several of the larger rivers of today are dotted on the figure. The points of agreement are indeed few and small. Perhaps the most important ones are that the Broad Top region is drained by a stream, the Juniata, which for a short distance follows near the course predicted for it, and that the Nittany district, then a highland, is still a well-marked divide, although now a lowland. But there is no anthracite river, and the region of the ancient coal basin lakes is now avoided by large streams. Conversely, a great river, the Susquehanna, appears where no consequent river ran in Permian time, and the early synclinal streams frequently turn from the structural troughs to valleys located on the structural arches. 28. Lateral water gaps near the apex of synclinal ridges. One of the most frequent discrepancies between the hypothetical and actual streams is that the latter never follow the axis of a descending syncline along its whole length, as the original streams must have done, but depart for a time from the axis and then return to it, notching the ridge formed on any hard bed at the side instead of at the apex of its curve across the axis of the syncline. There is not a single case in this state of a stream cutting a gap at the apex of such a synclinal curve, but there are perhaps hundreds of cases where the streams notch the curve to one side of the apex. This, however, is precisely the arrangement attained by spontaneous adjustment of an initial axial course, as indicated in Figure 13. The gaps may be located on small transverse faults, but as a rule they seem to have no such guidance. It is true that most of our streams now run out of and not into the synclinal basins, but a reason for this will be found later. For the present, we look only at the location of the streams, not at their direction of flow. As far as this illustration goes, it gives evidence that the smaller streams at least possess certain peculiarities that could not be derived from persistence in a previous accidental location, but which would be necessarily derived from a process of adjustment following the original establishment of strictly consequent streams. Hence, the hypothesis that these smaller streams were long ago consequent on the Permian folding receives confirmation. But this says nothing as to the origin of the larger rivers, which might at the same time be antecedent. 29. Departure of the Juniata from the Juniata-Catawissa syncline. It may be next noted that the drainage of the Broad Top region does not follow a single syncline to the anthracite region, as it should have in the initial stage of the consequent Permian drainage, but soon turns aside from the syncline in which it starts and runs across country to the Susquehanna. It is true that in its upper course the Juniata departs from the Broad Top region by one of the two synclines that were indicated as the probable line of discharge of the ancient Broad Top Lake in our restoration of the constructional topography of the state. There does not appear to be any significant difference between the summit altitudes of the Tuscarora-Mahoney and the Juniata-Catawissa synclinal axes, and hence the choice must have been made for reasons that cannot be detected. Or it may be that the syncline lying more to the northwest was raised last, and for this reason was taken as the line of overflow. The beginning of the river is therefore not discordant with a hypothesis of consequent drainage, but the southward departure from the Catawissa syncline at Lewiston remains to be explained. It seems to me that some reason for the departure may be found by likening it to the case already given in figures 16 through 18. The several synclines with which the Juniata is concerned have precisely the relative attitudes that are there discussed. The Juniata-Catawissa syncline has parallel sides for many miles about its middle, and hence must have long maintained the initial Juniata well above base level over all its distance. The progress of cutting down a channel through all the hard carboniferous sandstones for so great a distance along the axis must have been exceedingly slow. But the synclines next south, the Tuscarora-Mahoney and the Wiconisco, plunge to the northeast more rapidly, as the rapid divergence of their margins demonstrates, and must for this reason have carried the hard sandstones below base level in a shorter distance and on a steeper slope than in the Catawissa syncline. The further southwestward extension of the Pocono sandstone ridges, in the southern than in the northern syncline, gives further illustration of this peculiarity of form. Lateral capture of the Juniata by a branch of the initial Tuscarora, and of the latter by a branch of the Wiconisco, therefore seems possible, and the accordance of the facts with so highly specialized an arrangement is certainly again indicative of the correctness of the hypothesis of consequent drainage, and this time in a larger stream than before. At first sight, it appears that an easier lateral capture might have been made by some of the streams flowing from the outer slope of the Nittany Highland, but this becomes improbable when it is perceived that the heavy Medina sandstone would have to be worn through, as well as the repeated arches of the carboniferous beds in the many high folds of the Seven Mountains. Again, as far as present appearances go, we can give no sufficient reason to explain why possession of the headwaters of the Juniata was not gained by some subsequent stream of its own, such as in Figure 18, instead of by a side stream of the river in the neighboring syncline. But it may be admitted, on the other hand, that as far as we can estimate the chances for conquest, there was nothing distinctly in favor of one or the other of the side streams concerned. And as long as the problem is solved indifferently in favor of one or the other, we may accept the lead of the facts and say that some control not now apparent determined that the diversion should be as drawn. The detailed location of the Juniata in its middle course below Lewiston will be considered in a later section. 30. Avoidance of the Broad Top Basin by the Juniata headwaters. Another highly characteristic change that the Juniata has suffered is revealed by examining the adjustments that would have taken place in the general topography of the Broad Top district during the Perm-Triassic cycle of erosion. When the basin, Figure 22, was first outlined, centripetal streams descended its slopes from all sides, and their waters accumulated as a lake in the center, overflowing to the east into the subordinate basin, in the Juniata syncline alongside of the larger basin, and thence escaping northeast. In due time, the breaching of the slopes opened the softer Devonian rocks beneath, and peripheral lowlands were opened on them. The process by which the Juniata departed from its original axial location, as shown in Figure 22, to a parallel course on the southeastern side of the syncline, as shown in Figure 23, has been described. See Figure 18. The subsequent changes are manifest. Some lateral branch of the Juniata, as in Figure 23, would work its way around the northern end of the Broad Top canoe on the soft underlying rocks and capture the axial stream that came from the depression between Nittany and Kishiquaquilas highlands. Thus reinforced, capture would be made of a radial stream from the west, the existing Tyrone branch of the Juanita. In a later stage, the other streams of the western side of the basin would be acquired, their diverter constituting the little Juniata of today. And the end would be when the original Juniata, as in Figure 22, that once issued from the subordinate synclinal as a large stream, had lost all its western tributaries, and was but a shrunken, beheaded remnant of a river, now seen in Alwick Creek, as in 24. In the meantime, the former lake basin was fast becoming a synclinal mountain of diminishing perimeter. The only really mysterious courses of the present streams are where the little Juniata runs in and out of the western border of the Broad Top synclinal, and where the Frankston branch of the Juniata maintains its independent gap across the Tusis Mountain, Medina, although diverted to the Tyrone or main Juanita by Warrior's Ridge, or Iscani, just below. At the time of the early predatory growth of the initial diverter, its course lay by the very conditions of its growth on only the weakest rocks. But after this little stream had grown to a good-sized river, further rising of the land, probably in the time of the Jurassic elevation, allowed the river to sink its channel to a greater depth, and in so doing it encountered the hard Medina anticline of Jack's Mountain. Here it has since persisted, because, as we may suppose, there has been no stream able to divert the course of so large a river from its crossing of a single hard anticlinal. The doubt that one must feel as to the possibility of the processes just outlined arises, if I may gauge it by my own feeling, rather from incredulity than from direct objections. It seems incredible that the waste of the valley slopes should allow the backward growth at such a rate as to enable it to capture the heads of the other rivers, and so on, before they had cut their beds down close enough to the base level of the time to be safe from capture. But it is difficult to urge explicit objections against the process or to show its quantitative insufficiency. It must be remembered that when these adjustments are going on, the region was one of great altitude. Its rocks then had the same strong contrasts of strength and weakness that are so apparent in the present relief of the surface, and the streams concerned were of moderate size, less than now. For at the time, the Tyrone, Frankstown, and Bedford head branches of the Juniata had not acquired drainage west of the great Nittany-Bedford anticlinal axis, but were supplied only by the rainfall on its eastern slope. See section 39. And all these conditions conspired to favor the adjustment. Finally, while apparently extraordinary and difficult of demonstration, the explanation, if applicable at all, certainly gives rational correlation to a number of peculiar and special stream courses in the upper Juniata district that are meaningless under any other theory that has come to my notice. It is chiefly for this reason that I am inclined to accept the explanation. End of section 4A. Recording by Kelly Dolan.